Hi, welcome once again to this video. We have a question here that reads, the figure below shows a circle, center O, with line POS as diameter. QOR is an equilateral triangle and PT is equals to ST. Given that angle POQ is equals to 64 degrees, find the size of angle PTQ, angle QTR, angle STR, and angle SPT. Okay, so this is where we want to begin. We have been told that QOR is an equilateral triangle. That is very important. So our O is here. So QOR is an equilateral triangle, meaning that all these sides are equal and that the angles inside that triangle are 60 degrees each. So that's done. Then we are told that PT is equals to ST. Where is our PT? PT is here and ST is here. So those two sides are equal. Now there is something important. When two sides of a triangle are equal, the base angles are equal. That triangle is called isosceles triangle. Alright, so that's cool. So if we told that this is the diameter actually, PS through O is the diameter of this circle. That is another important fact that we shall use to get started, because I know that POS, and I believe you also know, that POS subtend 90 degrees at the circumference. Actually, POS is a chord. In fact, diameter is a special type of a chord that divides the circle into two equal segments. Cool. So this diameter subtends an angle 90 at the circumference. That's said and done. Then if this is 90 and base angles here are equal, then this is a 45 degrees. Alright, so another thing that we're going to do, we haven't started to answer the questions, but we will attack the figure here and try to actually determine those angles. By the time we are going back to the question, maybe we shall be able to, or we shall have done a lot. So let's see what we can do next. Now we have this triangle here, we are calling it isosceles, equilateral triangle. This part here, this line, we call it a chord. Now chord QR subtends angle 60 at the center, and that angle must be equal to twice this angle. So if this is 60, this is 30. Actually, we say that when a chord subtends an angle at the center of a circle, that angle is twice the angle subtended by the same chord at the circumference of that circle. So this angle here is 30 degrees. Cool. Alright, so if you look at this chord here, chord PQ, it subtends an angle of 64 degrees at the center of this circle. Then the same chord happens to subtend another angle at the circumference. Having seen that whenever a chord subtends an angle at the center is always twice the angle subtended by the same chord at the circumference, then half of 64 is 32 degrees. Alright, so allow me to use this straight line here and determine this angle. So if this is 64, this is 64, this is 56. Alright, because angles on a straight line add up to 180. So again, you permit me a little bit to extend this chord here, and you can see that this chord subtends an angle of 56 here, and the same chord happens to subtend an angle at the circumference, particularly at a point T. And so if this is 56, this is half of that, which is 28. Actually, that confirms a point that I said earlier on, that this angle must be 90, and we can confirm that. So you can take 32 plus 30 plus 28. That's 90 degrees. So you can see that this chord here, the POS as the diameter, subtends angle 90 at the circumference. Okay, cool. So having said that, then I think we can go back now to the question and try to see whether we will be able to answer. Question number 1. Angle PTQ, 32 degrees. Cool. That checks. Then we go to angle QTR, QTR. Seems like we have it. 30 degrees, cool. Then angle STR, angle STR, STR. Okay, we have it. Then we have, that's 28 degrees actually. Then finally SPT, SPT, SPT 45. So you can see how you can fundamentally determine the angles by understanding the laws governing the chords inside a circle. Actually, it is very important to remember that when a chord subtends an angle at the center of a circle, that angle is twice the angle subtended by the same arc or chord at the circumference. That is very important. Another thing is that when a diameter subtends an angle at the circumference, that angle must always be right angled. That must be 90 degrees. So again, other properties of triangle, I believe you know, right from the elementary levels of your schooling. You know that when you have an equilateral triangle, that is a triangle with all sides equal, and that interior angles are 60 degrees. Okay, so with that plus many more, you'll get to understand even we can have a situation where a chord and a tangent actually. So you may have a tangent like that, and you are told that this angle here, for example, if this angle is 15 degrees, which other angle is 15 degrees? If this is a tangent, then you must understand that when a chord and a tangent form an angle here, that angle is the same as up here. If and only if you have a chord and a tangent. Watch my videos. I will be doing a question of the same in the next video. Thank you.